Okay, welcome to the Jinbu chemistry lesson, and this is the first lesson. So let's start off nice and simple with some basic lab safety and measurements. Very basic measurements. So this is, as you can see, a general overview of the periodic table. For now, you don't need to know too much about this. Later, we will learn more about the periodic table. So this is called the NFPA safety diamond or the NFPA diamond. So what it does is for a certain element, it it has like different numbers for different colors. So you will know that all the different colors mean different things, and all the numbers means how dangerous it is. So it's from a scale from 0, which is like no risk, perfectly safe, to 4, which is like high risk. And in here we've got 1, we've got, oh, my drawing is a bit off, 2, and 3. So basically, the blue color, it means health. So if this chemical, for every chemical, this like NFPA diamond is different. I'm not sure which element this is for, but apparently there's a okayish high rate for you to get sick when exposed to this, because blue is the health hazard and 3 is the level. So the health hazard is about 3 dangerous, which is about pretty dangerous, and it's also very flammable. Flammability means if it burns easy or not. So in this case, it'll burn very easily. Well, not extremely easily, but normally easily, because it has a 3 here. So red, fire is red. And flammability is like, just like burn, how likely is it to burn? For example, let's say gasoline. Gasoline has a okayish flammability, while I don't think you can set water on fire without gasoline, so water has a low flammability. And it's represented by the red color. This is the reactivity hazard here. So reactivity just means whether it will react with other elements or not. For example, if we burn, say, an element, magnesium, and this element, when it burns, it'll emit light. Because burning is just speeding up a reaction between this and oxygen. There are oxygens in the air, by the way. So burning is just a way to speed up reactions, and burning magnesium is just a way to speed up reactions between magnesium and oxygen. So they will react. And apparently this element is okay in, well, reacting. It won't react very violently, but it will still react. And the white is the special hazard. So this little thing means it'll react with water. A huge O here. Sometimes you'll see flames in front, on top of the O, sometimes not. But an O means oxidizer. Okay, so now let's talk about how chemicals can like get into your body. First is by absorption. So for example, if some chemicals spilled on your skin, your skin would absorb the chemical, so it'll go into your skin and into your body. Inhalation is when you breathe in chemicals, and ingestion is when you eat or drink chemicals. These things happen every day. We inhale oxygen, inhalation. Our skin, well, it absorbs a teeny tiny amount of water, not a lot, so I guess we can say that. And for ingestion, we eat and drink every day. Yeah. So food, etc. So those are 3 ways how chemicals can get into your body. Now let's take a look at some of the things, some of the lab equipment. First is the Erlenmeyer flask or flask, and it's this thing. This one is used to sort of observe reactions, and this is the beaker used to contain chemicals. This is the funnel. So basically, what you do is there's that special type of like there's a special type of paper called filter paper, and then like you put it inside, you fold it in a special way and put it inside, and when you pour, for example, sand water in here, or dirt water, like the particles will get filtered out while the liquid would drop down here. This is the graduated cylinder used to measure things, measure liquids, solids, etc. This is the test tube, observe chemical reactions, and this is the Bunsen burner. So this thing, well, basically it burns. And this is a dropper. So you squeeze this little thing here, and it will absorb the liquid it's in. And when you squeeze it again, it will, well, spit those liquids out. So a measurement, like of length, of weight, of mass, of density, of anything, have to contain first a number, which is like the scale, the magnitude, how large this is, and a unit. For example, if I just have a 1 here, who knows if this is for density, length, weight, mass, who knows? So if this is for like mass, I would write 1 gram. So, well, the gram can stand alone by itself also, because how many grams? This isn't a complete measurement. So a complete measurement have to contain a number and a unit, 2 meters, etc. Units can have prefixes. So the K one, as you will probably know from km, is kilometer. K is like 1,000. So we've got one last slide here, which is all of the prefixes and what they mean. So we've got the giga, which is 10 to the 9th, the mega 10 to the 6th, the kilo 10 to the 3rd, the deci 10 to the -1, which is just this. The centi, milli, micro, nano, pico, etc. So 1 teaspoon of something is 5 milliliters, and 1,000 milliliters equals a liter. 1 liter equals a decimeter cubed, and 1 meter approximately equals 3.3 feet. 1 kilogram approximately equals 2.2 pounds. The ib here is just pounds. 1 liter is approximately equal to 0.3 gallons. 1 Kelvin is equal to so Kelvin is the basic standard measurement we use in chemistry, and it's basically like the degree Celsius plus this number. And the lowest temperature possible is 0 degrees Kelvin. So basically the lowest degree possible is like negative 273.15 degrees Celsius, just like that. So this is a conversion between Celsius and Fahrenheit. You don't really have to remember this, but it's good to know. So that's everything for today, and I hope that you've learned a lot. See you next time.